This is G481 homework booklet question 27. So we've got the terminal velocity of a raindrop falling vertically through the air is 4 meters per second. We're asked first of all to, in terms of the force acting on the raindrop, in terms of the force, explain why it's at terminal velocity. So if it's asking me to answer that in terms of the force, then I do need to name those forces, and it's at terminal velocity simply because the weight equals the drag in size. Obviously they're in opposite directions. That's what we needed. We needed to name the force and to say that in that equilibrium position, terminal velocity, those two forces are the same. The clue here in terms of the forces, that's really why it's not just enough to say that the forces are in equilibrium. It's got to be in terms of those specific forces. The next diagram shows a vector diagram for the falling raindrop on a horizontal crosswind of a speed 1.5 meters per second. First part of the question, it asks us to draw an arrow on the raindrop to show the direction which it'll travel. So I've kind of at least mentally added up the 1.5 meters per second with the 4 meters per second, and that's going to give me a final velocity down in that direction. So that's what I needed. So the arrow's got to be on the raindrop, as it said in the question, and it's got to be down and to the right. And then it asks us to calculate the magnitude of the resultant velocity. Again, I've got that little vector diagram, the 1.5, add on the 4 meters per second. I've got to work out the size of that. Obviously the horizontal force is at 90 degrees to the vertical force, so I've got a right angle triangle, a little bit of Pythagoras, and that takes me to v squared is 1.5 squared. So for that side, v squared is to 1.5 squared plus 4 squared, and if you do the sum, that brings you through to 4.27. I've just recorded that as 4.3 to two significant figures. So that was G481 homework booklet question 27.